G'day guys, just going to do a video just to explain what are the components, the individual components to make up a lithium battery, and we're just going to use a 12 volt battery, 12 volt system for this example. So when you buy a battery off the shelf, it is complete in a case with handles, and you've got two terminals, positive and negative. That's your battery complete. But if you were to build it yourself from individual components, it would look something like this. So the components that you need to build is, you need the battery cells, that's number one. You need the bus bars to connect, and you need, which are these bus bars, and you need bolts, which are these, to hold the batteries together. And you need a battery management system, a BMS, such as this. This is a BMS, which this is as well, and I'll explain that in a second. And this is a cell balancer, cell balancing, to keep your cells balanced throughout its life cycle, the lifetime of the cells. So let's go ahead and explain how you put together. For a 12 volt battery, you need 4 cells. 3.2 times 4, nominal 3.2 voltage, it is 12.8. So it is a 12 volt battery. And regardless of capacity is what how long you can use it for, of course. But lithium iron phosphates, which these are, 4 cells makes a 12 volt battery. 8 cells makes a 24. Let's not get too confusing. Let's keep it simple. 12 volts. So we've got 1, 2, 3, 4. And how is it put together? You need to start with a negative, or you can start with a positive, but we're just going to start with a negative. So this is the start of the battery. Notice that this is the start. This is connected to nothing else except the start. That's the start. Negative across to the other side is your positive. And you've got a bus bar to connect to the negative of the second cell, all the way to this side, which is a positive, as you can see here, via the bus bar to a negative of the third cell. Going across, positive, via a bus bar, copper bus bar, to the negative, and which at the end of it is what? It's your positive. So essentially, you've got your negative of your battery and your positive of your battery. So if you were to put a load, you can get power. And what you need to do is, we need to protect the battery. So if you were to just use this as the main positive, this as your main negative of your battery, you're running the battery without any intelligence, any battery management system. You're running it just raw, and you can overcharge it if you use a too high of a voltage, and most likely is you over discharge, meaning you would hurt your battery cells, because these can go down as low as about 2.5 volts. And with a BMS, it actually will turn off. So what the BMS does is, so this is a BMS, battery management system. And this one here is the 200 amp that we sell 90% of the time to customers. But the one that you see here, this is a skeleton of a BMS. So this is my 400 amp test BMS. It's just got the aluminium heatsink missing on both sides, but as you can see, it is much bigger, way chunkier and thicker once you put the aluminium heatsink. But so this is just for testing purposes. So as you can see, with the BMS, there is sensing cables. Can you see that there is 1 black on the left, then you've got 4 reds? Why is that? Because 1 black on the negative, and then that's your first red, that's your second red, that's your third red, and that's your 4th red. So there's actually 5 points on a 12 volt battery. A 4-cell battery has 5 points of sensing to the BMS, which is these wires. 1 black, 4 reds, and it's all in order. It goes along. First the black, first white, second white. First red, second red, third red, 4th red. Once again, first black, first red, second red, third red, 4th red. So that was all. They'll be all can be explained through a diagram. But let's just move along. The intelligence of the BMS is to watch on a cellular level. So it's not watching an overall voltage. It's actually monitoring individual cells via these sensing cables. So it would know exactly when any of these, where the voltage is of these individual cells. So it watches for 2 things, pretty much. One thing is the voltage on the upper limits. So when any of these cells reaches 3.7, so that's the upper limit threshold, the over voltage protection, it will turn off the output. So this is, and when any of the cells reaches the low voltage cutoff, the LVC, it is set at around 2.4 volts, 2.5, 2.4 volts, when any of these cells hits that, and then it's going to turn off. So how does it actually turn on and turn off? Very simple. Can you see this? This is the negative. The negative comes out and it goes onto the B negative of the board. If you can just see it from here in the camera. Just tilt it a bit. There we go. B negative across here. And this is a P negative. This is the output, the power, the load. So you can think of it, this is the intelligence. It is a electronic fuse, as to say. So these are the MOSFETs. See all this lovely solid state electronics, and it's double-sided here as well. And that is what handles all the current that needs to flow from your battery to your appliance. So this has to be up to the job. If not, they'll burn out. So if look, for example, if the quality on these are lousy, you try to pull. If they're not rated for what they're rated for, you burn the BMS out. No danger as in blowing up. When they burn, it's just open circuit. You've got no power coming out of your battery. So as you can see, let's just move forward and see how it actually turns on and turns off power. So this is my little 12 volt light, automotive globe, the old style. Let this level up. So I'm just going to plug it. We're going to try plugging it in straight to the battery. So this is not going through the BMS. We're straight onto the battery, and we're going to go straight onto the battery here, like so, and you can see that this light has lit up. There we go, nice and bright. Put that here, keep it from melting the table. Now we're going to take it on the protected side. So I'm going to take it off. So this is unprotected from the battery, and now this cable is going through the B side, and it's coming out through the P side of the BMS, which is essentially, let's have a see if I can bring it up this way, over here. There we go. Can you see how this is protected? This is running now, being protected. And to test your BMS working or not is one simple thing. We'll unplug the BMS from here. So remember, the BMS is, in this instance, it is letting power through the battery management system. So it's going through all these MOSFETs, the lovely MOSFETs, and is letting power through. But let me unplug the BMS, meaning the BMS is not getting any signal. There we go. I've unplugged it, and watch it. Can you see that? The light has turned off. So that means there's no more power going from this point to this point via all the MOSFETs. The BMS has protected your battery. So this is the intelligent board that you install and forget. Our BMS systems don't have Bluetooth, don't have any other comms, just a install and forget. Now we've re-plugged it in, so we need to disconnect the load. The BMS resets, put the load back on, and the light comes back on again. So once it protects, you need to remove the load. It's on. Something goes wrong. The board is not sensing any information. The board is not getting data. Why? Because the data is through this port, these multiple cables. So what we do is we put the make sure that it has data. There we go. It's sensing all the voltages now. Plug in the load. Bingo. She works. Beautiful. So that's your BMS system in a simple explanation. Now moving on. Cell balancing. This is a $35 cell balancer, and for $35, not to have one would be, for 35 bucks, to have the benefits of cell balancing, it makes sense just to have one. On new cells, generally, you don't really, if you don't want one on a new cell, you can opt not to. On a used cell, then we recommend having cell balancing. Second-hand cells, that is. But even for a new cell, in the long run, 35 bucks for a 12-volt system, it is not much for the benefits that you will have in the long term. So the connection of the BMS, of the battery management board is the same way as you would do the BMS. Can you see that? On this balancing board, there is one black, one red, two red, three red, four red. So you've got 5 cables. So you attach it in the same points. One black, first red, second red, third red, fourth red. So total 5 cables. So after you made the connection, essentially it's the same thing as this. They share the same plug. I can happily plug this into here, and there we go. So now she's all connected and she's system go. Now this will only activate, see that there's 3.55 volts. So this will only activate when any of the cells, as you're charging up, once it hits 3.55, then the LED would light up to showing you which cell is being balanced. Generally speaking, you have everything in the case, you wouldn't even see this light coming on and coming off and doing its job. You'll be installed, aluminium heatsink on the top. Keep this side away from the battery, and of course put your insulation, and when you double-sided tape, insulation, and then of course you can have a insulation on this side as well before it goes onto the side of your case. So a battery, the battery it doesn't have a case. It is 4 cells. Whether you strap it, whether you duct tape it, whether you just wrap it up so it doesn't move. One thing to note is you don't want it to move to actually give stress on these joints where the bus bars and the bolts are. So the casing solution is up to you. Use your imagination. Put it into a plastic battery box that holds AGMs, or if you're handy, get some plywood, get some MDF or whatever, knock up a box, build an enclosure. All you want to do is make sure that these terminals and bus bars, and of course you would tidy up your cables. This is just my testing rig, so I can undo this, remove all the ring tab terminals and use it on another battery for testing. So this is my basically testing BMS with the sensing wire removable, and that's it. So the case that you have it, if you're wanting to use our battery case that we sell, you would run a cable from here to the underneath of the battery case, which is a bolt, and then you terminate it. You basically put a bolt, tighten it up so it's attached, and on here through the BMS board. So this is the output cable. So this is just very long because I'm using it for testing, but you would basically put a bolt to the negative side of the battery lid, the battery case lid, so that once you're finished, you've got a battery box with a negative and a positive bolt on top, just like a traditional battery. So in essence, you've built your own battery from scratch, and this is what it looks like from scratch. Battery balancing, BMS, battery management system. So this is usually in place of this, the black one, but the black one is just my testing rig that I use. And yeah, so hopefully that gives it a bit more of an insight on what's needed to happen for you to DIY. Just some extra clarification on a battery management system. You've got your sensing wires, which we've covered, and then you've got your battery negative, battery minus, and then you got your P minus. So the battery minus is the input. In the input, and where does it come from? It comes from the negative of the battery. So the negative of the battery, as you can see over here, it goes to that board, but let's just explain it on this board. This cable would go to here, and then this will go to your load. So this is where you're using the power on the negative side from. So, and it's protected via the middle part of the board. So whether this turns on and gives you power, or it turns it off and cuts power. So there's nothing reading from here. Once again, input, output, negative. This is a negative BMS. Negative input to here, negative output to your load. Sensing wires. Okay, there we go. So that's BMS. And just to quickly explain, I didn't touch on how it actually balances your battery. So with this plugged in, it senses via these cables, and what it does is it's got big resistors in there. Can you see? There's actually 4. There's 1, 2, 3, 4. The 8 cell, which is a 24 volt, uses the same board, and just that you've got more parts put on, and you've got more resistors put on. So basically, we're utilizing half of the real estate for a 4S 12 volt. If it's a 24 volt, we use the rest of the space with components. So when any of the cells reaches 3.55, the resistors go to work. And via these little thin cables, which is more than enough, it would start discharging, pulling. The resistors causes heat. It's like a little heater then, and you pull the voltage that is high, you pull it down. So when it senses number 1 cell, number 2, number 3, number 4. If you have a balanced cell, all the 4 lights should turn on approximately at the same time. They'll be like ding, 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 4 lights on. That means your cells are all very balanced. They're all hitting 3.55 at the same time. If they are not, the one that will turn on first will get pulled down, allowing the others to come up, and then they will pull down, come up, and then before you know it, it has done its job. You've got a balanced cell. So it does. So the balancing method is by resistors, which emits heat, which gets translated into heat. Therefore, you need a nice heat sink on here, and it does get warm, so which is normal, but the cables do not get warm. So that's it. That's the balancer and how it works.